Hi there. My name is April. I am a mechanical engineering student with a minor in aerospace.
I'm Tareen, and I'm a software engineering student.
I'm Paris, and I'm a mechanical engineering major, minoring in aerospace.
Hi, I'm Brad. I'm a chemical engineering student with a minor in digital engineering.
Today we'll be presenting on the Titan submersible incident. This was an event that was quite shocking in that it revealed deeply concerning violations of engineering ethics. This case ties together the risk of innovation and engineering responsibility, which we'll discuss through both technical and ethical lenses. The Titan submersible was a deep sea submersible designed to take up to 5 passengers. It was operated by OceanGate Expeditions and intended to take tourists, scientists, and researchers to the Titanic wreck, which is 3,800 meters below the surface of the Atlantic Ocean. However, seeing the Titanic wreck doesn't come without its risk when dealing with high pressures due to extreme ocean depths. On June 18th, 2023, the Titan submersible descended to the Titanic wreck with 5 passengers on board. Approximately 2 hours into the dive, the submersible was declared missing. Search and rescue parties were sent out and continued for a few days with hope that the crew were still alive. However, it was found to have imploded after finding the wrecked debris in the of the submersible. Notably, what was more shocking about this event was that this marked the first fatal accident in a manned deep sea submersible in over 50 years. Moving on to some of the technical details that played a part in the failure of the Titan submersible. The Titan submersible used an experimental design that differed from a typical engineering design of a submersible. Instead of a traditional spherical metal hull, it used a carbon fiber cylindrical body with titanium end caps. These materials do not perform the same under different compression and thermal conditions. This mismatch caused stress points, especially under the extreme pressures at depths of 3,800 meters. Moreover, the use of carbon fiber, while lightweight and cheaper, is less reliable under compression and more prone to fatigue and manufacturing defects. Additionally, the Titan's non-spherical hull shape was pushed to be designed to fit more passengers for more profit. This led to uneven pressure distribution, introducing further structural risk. These technical designs that were made in pursuit of innovation and profit compromised the vessel's safety, which led to multiple fatalities. And so in the next section, we'll explore the ethical violations in more detail.
There were many ethical dilemmas, but I'm going to talk about two main ones. The first one being how they prioritized innovation over safety. As Paris mentioned, the use of carbon fiber for the hull in place of traditional materials such as titanium or steel was a main factor. They also bypassed traditional safety certifications. The Titan submersible was never certified or classed due to its unusual design. And this culture of prioritizing innovation over safety stemmed from CEO Stockton Rush, who was also the pilot of the Titan submersible. He's on the record quoting that safety is a complete waste and that it should not be prioritized at all. This all led to the disaster. The APEGA rules of conduct that were not followed here could be rules 1 and rules 4, where engineers should hold paramount to health and safety, and they should also follow all regulations and bylaws. The second ethical dilemma was the failure to fully disclose known risks. It was the failure to conduct their operations with integrity and honesty. A major example of this was when David Lockridge, a whistleblower and former engineer at the company, came forward with concerns about the structural integrity of the submarine. but these concerns were suppressed and dismissed by the company. They also hired inexperienced crew members because the CEO, quote, wanted his team to be younger, to be inspirational, and not have older people working for some reason. This failure to hire experienced people when he could, and this failure to fully disclose known risks are in violation of rule of conduct number 3, where professional engineers should conduct themselves with integrity and honesty. And then over here on the right, we have an image of the crash as well as the whistleblower testifying.
So to sum it up, based on the APEGA rules of conduct discussed in class, the three most significant violations in this case were Rule 1, because public safety and welfare were not prioritized through the submarine's design and deployment. There were also major deficiencies in professional leadership, and whistleblowers and safety concerns were repeatedly dismissed. Rule 3 was also violated because the CEO allowed his personal opinions and ambitions to override ethical engineering practices, compromising the team's integrity, and the engineering team as a whole lacked transparency and objectivity. And then Rule 4 was also compromised because numerous applicable regulations and engineering standards were disregarded during the project. So as a violation of Rule 1, naturally, the engineers did not design with safety as their top priority. All submarine designs involve inherent risks due to the complex underwater environment. However, engineers have an ethical duty to address these risks responsibly. In this case, critical trade-offs related to safety were poorly handled. OceanGate's engineering team failed to allocate sufficient resources, both time and funding, to ensure the vessel's structural safety. This negligence was rationalized under the label of experimental design. For example, choosing the carbon fiber hull was, even though it was a less proven material for deep sea vessels, demonstrated that there was a preference for innovation and cost efficiency over safety. Despite warnings and advice from other professionals to conduct stress tests and simulations, these recommendations were ignored because they were seen as time-consuming. The emphasis on rapid development ultimately placed lives at risk. A stronger focus on safety in the design process could have prevented this tragedy. So, as discussed in class, engineering leadership is an approach to influencing others to effectively collaborate and solve problems. In this case, there was a clear lack of such type of leadership, as those in charge refused to engage with experts to properly address and resolve critical safety concerns. The key leadership failures in this case include emotional and biased decision-making from the CEO. He allowed personal beliefs and ambitions to override rational, safety-focused engineering judgments. There was also mismanagement of priorities. Safety was repeatedly compromised in favor of time efficiency and cost savings. And there was also a lack of transparent communication because OceanGate's leadership failed to clearly communicate the risks of the expedition to the crew members and to the public. And there was also a lack of accountability. The company consistently downplayed safety concerns and failed to take responsibility both during the development phase and after the tragedy. This case illustrates how the absence of ethical leadership and sound decision-making can lead to avoidable tragedies, reinforcing the critical importance of adhering to professional codes of conduct in engineering practice. It also raises a crucial question for reflection about how engineering teams can maintain objectivity and ethical standards when working under strong influence from powerful or visionary leaders with opposing views.
One of the most important things that I have taken away from this class has been the ability to ask questions. Learning about the shortcomings in the engineering community and what caused them has allowed me as an individual to develop a strong moral compass when it comes to the questions that I have and the answers that I need in order to create a project that I feel proud of. The following 3 questions outline the open-ended discussions that I hope each person has in their upcoming career, along with further research projects in the future. The first question is, what are the regulations put in place to keep engineers from building whatever they want? For example, the crash of the implosion of the Titan, there were obviously regulations in place that should have kept the materials used and the combination of materials used from being used together, and that would have resulted in no fatalities. In addition to this, should engineers be able to design and develop whatever they want? If they like, this question is open-ended, right? It can be either or. Uh, Being able to explore creative options and creative solutions will continue to advance society in a positive way. It can also create tragedies like the Titan, or as mentioned earlier in the course, the Challenger accident. The next question would be, what engineering improvements have been made to keep this type of event from happening again? As an engineer, would these improvements actually steer you in a different direction? So one of my biggest takeaways personally of this overall class has been the sheer volume of engineering mishaps. And lots of them seem to be due to the same kind of core problems: lack of leadership, lack of communication between levels of companies. So even though we have all this research, like, is it being implemented in a way, or could it be implemented in a way that would actually steer engineers into a more positive uh, um, direction when they're building and designing things in the future? And finally, were there any structural or technical failure weaknesses that were overlooked by the engineer? Why were they overlooked? We know that there were structural things that were overlooked, and there is always when it comes to these types of incidents. Like, the question is why? Like, what is causing these things to be overlooked so frequently, and how can we diminish these when we're designing personally in our careers? The following slide concludes our presentation about the Titan Ocean Gate crash. The references are as shown. Thank you for watching our presentation. Hope you have a great rest of your evening.